Welcome to This Explainer. Today we're diving into the totally fascinating, super precise science of growing corals right in-house. You know, our natural reefs are under literally unprecedented pressure these days from warming waters and pollution. But thankfully, there's a proactive response. So today, we're looking at how in-house coral farming is really stepping up to rehabilitate these incredibly fragile ecosystems.
For way too long, the broader industry has kind of viewed corals as mere commodities, right? Almost like a rock you just pick up and drop into a tank. But the truth is, corals are a highly complex, incredibly picky animals. With our marine ecosystems under immense pressure, we absolutely have to fundamentally shift how we treat these organisms.
And this really gets to the core philosophy of modern in-house farming. It's about totally abandoning that unpredictable, kind of scary mystery shipment mentality. Instead, we're shifting the focus entirely to treating coral like the delicate, genetically complex biological system it actually is.
The ethos here is simple, but man, is it demanding. As this quote perfectly captures, rather than treating coral as an off-the-shelf product, we treat it like a living system, monitored daily, adjusted as conditions change, and documented end-to-end. This definitely isn't a set-it-and-forget-it kind of thing. It's a really rigorous, daily commitment to chemistry and biology.
Okay, let's take a quick look at the agenda. Today we're covering 1. Broodstock and genetics, 2. The controlled nursery, 3. Tailored maintenance, 4. The farm-to-tank transfer, and 5. Revolutionizing supply chains.
So, looking at the overarching farm-to-tank process, we get a really great high-level view of the 4 critical stages these resilient little organisms have to successfully navigate. It's a very deliberate, highly staged timeline before they ever reach a final display tank.
All right, let's start with Section 1, broodstock and genetics, selecting the parents.
This very first step establishes the genetic foundation for the entire operation. Before a single fragment even sees a nursery, the team conducts a super strict intake assessment. They prioritize genetic diversity and keep incredibly clear records of the coral's lineage and collection context. They're screening out visible diseases or structural fragility and assessing the coral's stress response. It's all about supporting long-term ecosystem resilience literally from day one.
Moving right along to Section 2, the controlled nursery, stable water, low stress.
Now, the carefully selected fragments move into an environment that protects them during their most vulnerable growth period. And here, stability is absolutely everything. You can't just fill a glass box with salt water and hope for the best. Farmers have to meticulously maintain stable temperature, controlled salinity, appropriate alkalinity, and precise calcium levels. It's like a delicate chemical dance to manage nutrients, ensuring the corals get exactly what they need so they don't starve, while also making sure nuisance algae doesn't completely take over.
But you know, it goes way beyond just the chemistry. They have to perfectly tune the physical environment too. Even tiny, seemingly insignificant changes in lighting intensity or water flow can drastically affect a coral's health. So these settings are constantly tweaked to meet highly specific, species-dependent needs.
Section 3. Tailored maintenance, targeted husbandry.
Maintaining coral is definitely not a passive job. Think of it more like a daily doctor's round. The team conducts frequent health checks, monitoring key indicators like coloration, polyp behavior, and tissue thickness. And they are constantly on guard against really dangerous stressors, things like tissue recession, rapid algal takeover, or localized bleaching.
Which brings us to a vital operational rule. If any of those dangerous stressors do actually pop up, they don't just blindly dump chemicals into the whole system. Actually, there is zero one-size-fits-all treatment here. Instead, they instantly isolate the affected colony, adjusted specific parameters, and carefully document everything. It is incredibly precise, individualized care.
Okay, on to Section 4, the farm-to-tank transfer, staged for success.
Everything we've talked about so far builds up to this highly anticipated move. But moving corals prematurely is honestly one of the biggest mistakes you can make. It just causes major setbacks. To avoid this, farmers track fragment growth rates constantly and monitor their stability. They essentially wait for consistent recovery and avoid premature moves at all costs. And when they do move them, they carefully control the acclimation to the new water chemistry.
Finally, Section 5. Revolutionizing supply chains, the bigger impact.
Let's zoom out a bit. What does this in-house model actually change at a macro level? Well, by controlling the entire workflow locally, these farms dramatically reduce the severe stress that traditional, long-distance shipping timelines usually inflict on marine life.
It also enables improved traceability, which is just a massive leap forward. For reef restoration projects, knowing the documented lineage and exact propagation history of a coral is absolutely essential. And even for display programs, this level of tracking guarantees reliable animal welfare.
Ultimately, the whole ethos of in-house farming is to deliver a healthy, well-adapted living organism, not some stressed-out mystery shipment pulled randomly from the ocean. It's a deep, ongoing commitment to biology.
Which leaves us with a really critical question to consider today. As global ocean temperatures continue to rise and local reefs face these unprecedented threats, how quickly can we scale these traceable in-house aquaculture practices to further protect our natural reefs from a warming ocean? Because doing so might just be our absolute most effective weapon to safeguard the future of marine biodiversity. Thanks so much for joining me on this explainer. Keep wondering, keep learning, and I'll catch you next time.